Welcome to today's webinar, Deploying Microsoft SharePoint Server on the AWS Cloud. Our presenter today is Matt Tavis, Principal Solutions Architect with Amazon Web Services. As a Principal Solutions Architect, Matt works on the AWS partner team with enterprise customers and partners to provide architectural guidance and to help AWS customers understand how to best utilize AWS. Matt has been with AWS since 2005 and has been working on Amazon's web services offerings throughout that entire period. Prior to joining AWS, Matt worked at Microsoft designing web services APIs and spent many years working in IT consulting for Sapient Corporation. Thank you for joining us today, Matt.
Thanks, Colin. So let's dive right in. We got a lot to cover. There's obviously a lot of detail associated with deploying an entire SharePoint server farm on top of the AWS cloud. So we'll jump right in and get started. So obviously this presentation, this webinar is backed by a significant amount of additional content and information. There's a white paper behind it, as well as CloudFormation templates that can automate the deployment of this entire infrastructure we're going to talk about today. So really the intent of this webinar is really to give you kind of the high-level steps and an overview so that you can choose to then dive deeper with the quick start reference implementation guide, as well as the CloudFormation templates we provide, so you can spin one up on your own, as well as tweak and tune it to fit your specific needs and configuration. We'll obviously discuss some core AWS services that are leveraged for this platform, as well as some of the SharePoint Microsoft specific components as well that sit on top. Obviously, links are provided here to the CloudFormation templates and in the white paper as well. A first thing to touch on is really how the Microsoft platform runs on top of AWS. So there's a couple of aspects around licensing and how those licenses move to AWS that are important to note up front before we dive too far into this. There's two major licensing models to be aware of. One is more of a pay-as-you-go pricing that includes the software, so the Windows Server platform. So when you spin up a Windows-based Amazon machine image, automatically AWS keeps track of the usage there, and we then pay for that license through the actual hourly rate for the EC2 instances running Windows. We also have pre-built AMIs that have included versions of various server software, such as SQL Server Standard, and those are also pay-as-you-go models. In addition to the pay-as-you-go, there's a bring your own or BYOL licensing model. So you can bring your own licenses over to the AWS platform. This whole model is made possible through the license mobility through software assurance model that Microsoft provides. So if you're a software assurance customer and have a software assurance licensing model with Microsoft, you can then choose to move those licenses into the AWS platform. So examples of that, if you want to use SQL Server Enterprise, SharePoint Server, Link, many other Exchange, many other Microsoft Server platform components are supported under this license mobility model. So it's important you take a look at the components you want to move over and be assured that they actually do move through that software assurance program. But today we're going to be talking about obviously Windows Server, Windows SQL Server Enterprise, as well as SharePoint Server. So all of those are covered under this licensing model. The pay-as-you-go AMI pricing is done for the Windows Server components, and then the SQL Server Enterprise and licenses are then bring your own licenses that you can bring over to the platform. For the trial or for this particular CloudFormation template, we embed and enable using the trial keys for these various pieces of software, which allows you to spin it up and try it out. However, if you were going to go into production mode, obviously you'd have to bring your own licenses. So what we're going to cover today is a few different pieces. Obviously, the architectural scenarios around how this is laid out. You can see a lovely diagram we'll break down over time. Server role architectures, so traditional versus streamlined topologies for the SharePoint farm. And then, of course, the steps to get going for this quick start and what needs to happen. And I'll actually spend some time looking at the CloudFormation templates to show you what's behind this and some post-configuration steps as well. So architectural scenarios. The first thing to focus on, and we're obviously assuming a lot of existing AWS knowledge here. So if you're not familiar with things like EC2 or VPC, those particular services, EBS, you definitely want to go back and spend some time looking at those particular services to know more about them. But in quick summary, the virtual private cloud or Amazon VPC offering allows you to provision a private isolated network where you can then deploy resources into the AWS. Now, this can be a standalone, private network entirely within the cloud. This can be a VPC that also extends your existing data center network. So you could have free flow of traffic on a common set of IP ranges, a 10 dot range, for example. So private addressing between your data center and Amazon VPC, or hybrid models in between. Lots of options there in terms of how you configure and deploy it. This is something you can dynamically provision through APIs, the management console, or CloudFormation templates like we will today, and allows you to spin that infrastructure up. From a high availability perspective, we think it's important that when you do deploy a VPC, you use multiple availability zones. And those are, you could think of those as distinct, physically separated data center models inside of a region. So they have fault isolation, power isolation, things like that built into them. So you have a higher availability footprint, but using a single region. So we always recommend using at least two AZs in each region. There's always two AZs available to deploy your infrastructure. And you can choose to use two AZs that are internet facing or two AZs that ultimately are just connected to your data center. So you have some choices there. So this is kind of our default model for recommendation. Additionally, we'll talk about our remote desktop gateway, which is how you would then go and administer this infrastructure. So speaking of that, remote administration, being that you're going to deploy and run an entire set of servers, SQL Server, IIS, SharePoint server, various components, there at some point you might need to get onto the box and administer it. Our recommendation is to always use a remote desktop gateway, which is the entry point into the rest of the environment. So using a gateway, you can jump, if you will, from that gateway server into any of the other internal private servers which are not directly internet accessible. So you can see in this particular model, if you had an internet-facing VPC that had a public subnet, and then you wanted to administer Windows Server instances inside of that, what you'd want to do is instead of making every single server in that VPC publicly accessible to the internet, you would make a remote desktop gateway server, domain joined, which you could then go ahead and access as your entry point, and then from there jump into the individual servers inside the environment. In fact, you can even configure it to do that as a proxy protocol, so it can bounce directly through. There's a lot more information on this. In fact, there's a whole other webinar that we did recently about the remote desktop gateway deployment administration on AWS. And so if you want to know more about how to set one of those up and how that happens, I would go listen to that webinar. This CloudFormation template that we provide does this for you. It spins up this remote desktop gateway infrastructure as well for administration. And there's steps in there to even post-launch and post-setup to move from a traditional RDP 3389 protocol to actually moving over to SSL 443 with certificates for even a more secure model, which is our general recommendation. So that's all covered as part of the remote administration desktop gateway webinar, but it's definitely a piece of this CloudFormation template as well, and it builds what we'd consider to be a standard reference implementation for any Microsoft platform, but SharePoint specifically will then leverage things like this gateway, Active Directory, SQL Server Enterprise. So, and that takes me to the next topic, which is Active Directory domain services. Obviously, in a Microsoft platform, Microsoft stack, authentication, domain joining are commonly done through Active Directory domain services. And so as part of this template, that also is deployed and configured. So when this environment is spun up, in addition to providing the remote desktop gateway, it also creates an Active Directory domain, which then all of the Windows Server instances join, giving you a unified user management model, a unified authorization authentication model, as well as a highly available model for failing over between domain servers inside the single region. So you can see the figure here to the right focuses mostly on a cloud-only solution, totally disparate. And in fact, that's what the CloudFormation template spins up, as a standalone Active Directory domain services domain. However, obviously in many cases, if you're in an enterprise, you might want to extend your existing Active Directory domain. So there are alternative models to this, and there's again, just like with the remote desktop gateway, there is another webinar that backs this as well, that's worth looking at, which is all about how to set up the Active Directory domain services. And in that, it actually has models to describe how you would spin up the infrastructure and then domain join those so they are read-only or even read-write domain controllers that extend your AD forest from your enterprise. So that's a totally reasonable model to then extend the enterprise Active Directory footprint into VPC. This scenario doesn't assume something behind the scenes, so you could use these templates as a baseline and then extend them or tweak them to leverage the existing domain services in the enterprise. And it's optional to deploy the domain controllers here in the cloud. Many people do for latency or performance reasons. But on top of that, you could make those calls all the way back to your domain controller inside of your private corporate network as well. So next we have to talk about server role architecture. So this is actually an important shift from SharePoint 2010. In SharePoint 2010, there were more what they call more traditional topologies, and this is some Microsoft terminology that applies to the actual server role architecture you use for deploying SharePoint. So in Server 2010, they would have called it, or SharePoint 2020, it would have been called more the traditional topologies. And now there's a new architectural deployment model for distribution of components called Streamlined Topologies. And I'll cover both of those in the next two slides. The traditional topologies sort of fits with what people are used to seeing from a classic web app architecture. Either two-tiered or three-tiered, where the two-tier model says I'm going to have my web and app servers, SharePoint installation on one tier in my entry point, if you will, to the application stack, and that will be backed by a database server. The three-tiered model allows you to distribute the web front end from the application server, so components such as Access or Excel, other things that are actually running on the server end to do simulation or access to more rich application environments might run on that application server, whereas you might run just the SharePoint front end components under IIS and the web front end server side. Still backed by a database server in the back. So this is, I think, what a lot of folks are familiar with when they look at existing SharePoint 2010 architectures, but this is totally doable with 2013 as well. You can deploy it in that way. And in fact, actually, that is an option in the CloudFormation template, is how do you want this deployed? More streamlined or more traditional? And you can see here's an example of how you might build up that 2013 farm with the traditional topology. You have to lean in close and stare at those icons and get out your reading glasses. But you can see on the left is the web tier where you've got obviously the remote desktop gateway and NAT components, but you can see there's a load balancer. So the users go through the internet gateway to an elastic load balancer, which distributes traffic to the SharePoint front end in the web tier. The next tier back then adds behind that. You can see now the web tier is still there, but now we've added two boxes in the middle in the application subnet, and that's running the SharePoint application services that extend on top of that. And then in that next layer back, what you're seeing is there's no longer load balancing because the web front ends are then aware of the application components as part of the SharePoint architecture, and then they talk to them. They specifically pick ones and choose those to work with at the next layer back. And then behind that, the database tier, you can see there's the primary and secondary replicas for the SQL Server Enterprise deployment. So the application servers don't need to be load balanced. The databases are going to focus. You're going to focus all your traffic on a primary and then fail over to a secondary when any kind of scenario like that occurs. So that's pretty much the traditional topology model. Streamlined topologies take a whole different approach and allow you to actually split common architectural components into different, if you will, clusters or groups of servers. So now you can actually break that down, and this is fits very, very well with how we think about the scaling at individual layers of an architecture, right? So as it turns out, when you're building an application, something so rich as, say, a SharePoint, there are different capabilities or different resources required for different functions in the architecture. So search, has a different footprint, a different resource need in terms of memory than, say, something like the web server, right? So, and the same thing with batch processing, same thing with caching, and even routing requests, so request management. So The streamlined architecture, streamlined topologies that Microsoft promotes, focuses on some of the core common architectural pieces. So the front end servers, think about the pages themselves, IIS, batch processing is that next layer back. In the batch processing, you're thinking about components, services, and service applications that process background tasks is the way to think about that. Um, the next layer back is then your database servers. This is no different than in the traditional model. So the database servers have the same tables, the same functions, the same capability as the traditional model. So that's kind of a consistent component or a consistent server footprint as to the traditional model. There is another layer called distributed cache. In a small or medium environment with say less than 10,000 users, you might put this on with the front end servers. You might compress them and say, oh, the front end, the distributed cache sits there with the front end server on that same box, right, as a model. As you get larger than that, because distributed cache is very, very memory intensive, you might move that out to a memory optimized footprint. You might choose a different instance type, for example, from the EC2 catalog that has a bigger memory footprint because that's what the distributed cache is going to be essentially run out of first from a resource perspective. The request management tier sits behind that, and that's really based on it's a routing rules engine, if you will, that allows you to route incoming requests to the right places. In a small environment, you could run that on the front end servers, and it could be installed together, or you could, as the environment gets larger, move it to the distributed cache layer, or even just a dedicated server footprint. So you really have choices how you deploy these components. And then, of course, there might be specialized workloads. So, for example, Excel calculation or performance point are common organizational components that might have a different need or a different footprint. And so in those cases, they would be moved to sort of more dedicated servers. Additionally, as I mentioned earlier, search is commonly a very sort of resource intensive and heavy kind of component, especially in larger farms. And so, as you scale beyond the two batch processing servers, it's very common to make search a dedicated server. It consumes a lot of system resources, and you can even actually point search at a distinct database. You could do a read-only replica, if you will, of the SQL Server Enterprise node and then point it at that, because search obviously isn't going to be writing the things, it's going to be finding things. So in that sense, you could use that as a way to offload some of the write-intensive workload and push that to the primary, and then do the read-intensive workload through search on a secondary. So that's a pretty common, architectural model for getting more capacity out of your system. There's also the Office Web Apps server. So this is a component that allows you to edit and view Office documents using supported browsers or various devices. And this is generally something that is, well, not generally, it is required to be run on a different set of servers in the environment. So if you do choose to use the Office Web Apps server, that would be another component at the front end layer. In order to get that set up, the CloudFormation template can spin one of those up, but there are post-configuration steps to make that work. The nice thing about these web apps is actually this can be shared by other applications. So SharePoint will use Office Web Apps, but it can also be used by Exchange or Lync 2013. So there's other architectural components that could leverage that Office Web Apps footprint. So you can imagine SharePoint being just one of many Microsoft platform services running on AWS, and others sort of sharing that Office Web Apps server. Now, there's also another model, which, of course, we've been focusing on in all of our architectural diagrams to this point, have been really focusing on the internet-facing, so public internet-facing architecture. But there's also the idea of an intranet. So many customers run SharePoint as an internal-only farm for document storage and collaboration and management. And so in that scenario, you may not ever want your SharePoint to be visible to the internet. In that case, you would change the architecture would change slightly, and it would go from a public subnet to only a load balancer, elastic load balancer that is visible only on the internal private network. So when you create elastic load balancers, you have the ability to define them as public internet accessible or private only. And if it's private only, it's only the DNS resolutions and its IP addressing would only resolve to the private network range, say a 10 dot of some variety, which is non-internet addressable. In this particular model, you could use the CloudFormation template to spin up the environment and then go back in and extend and connect it via a virtual private gateway and a VPN connection to your existing data center. And so you could say, I have a Cisco, a Juniper, a Viata, a Palo Alto device in my data center, and I want to use that to establish an IPsec VPN tunnel. And we can, once you've spun up the environment, you can then add a virtual private gateway to that VPC, and then go ahead and connect that to your VPN device, and then you can extend your existing private network into the VPC. Obviously, this is something that would require coordination with your network administrator to make sure you're not, don't have overlapping IP ranges, things like that. So you'd want to work with them if you want to carve out a VLAN specifically for this kind of scenario. So this enables your internal only connectivity. Alternatively, you can also use Direct Connect. So Direct Connect is a service that allows you to have a physical line from your data center to a data center near AWS or next to an AWS region, and then we can then connect that directly into the VPC itself. So now you have essentially a dedicated private link that is specifically used for AWS connectivity. That makes a lot of sense when you start moving significant amounts of data, or you have additional privacy concerns and you want to lock down and know the exact route so it never goes over the public internet explicitly. And it also allows you to identify which traffic you can say, I want my AWS traffic to go over a separate link and not impact my public internet connection. So another model as well to consider. So as I mentioned, the template allows you to choose how you want that load balancer to be visible on the public internet or only through private. And of course, the other aspect to think about when you're going through deploying one of these is what are the security requirements with regards to deploying this. And we have 3 different layers that you want to think about here. The first is our security group. So if you're not familiar with that, definitely worth a read. There's a lot of information about security groups in our security white paper, which you can find on the website under aws.amazon.com/security. And that actually allows you to define layered groups. The web tier can only talk to the app tier. The app tier can only talk to the database tier. All of them can talk to Active Directory. The remote desktop gateway can talk to all of them on different ports. And you can really control the ports and protocols of what servers can talk to whom. And you don't need to do it as an IP range thing. You can do it based on referencing other security groups. So it's what I'd call a stateful firewall that's at the hypervisor layer below the operating system. So we inspect traffic before it hits the instance, so we can make sure that it's going to the right place and that it is in fact allowed to bubble up to the operating system of the guest OS. Additionally, there's network access control lists. These are stateless layers between subnets that allow you to filter traffic before it even gets into the subnet itself. There's a kind of a component there where you can allow them to be separate. So one person could manage security groups and someone else could manage ACLs, network ACLs. Therefore, you can isolate, access control, so somebody couldn't make a mistake that would, violate the broader rules. Network ACLs do require a little more thought in the fact that they are stateless, so they don't keep track of connections. Therefore, you have to open both the inbound port as well as the outbound ephemeral response ports. So you have to think through what those are and spend time analyzing security. So those are definitely very powerful, but also require a little more thought. And then, of course, is the secure website publishing layer, which is you can add an additional layer of security by placing reverse proxy servers in your public subnet. And that would allow, if you can actually see them in this diagram, that would allow you an additional layer of isolation between your public subnet and your actual front end web server. You can also inject things like threat management components. This is not something we do as part of the template, but this is certainly something you could do to extend the template and provide that layer. And so you would then move your front ends back into the private layer entirely. And so you would then do a reverse proxy, which is maybe a thinner footprint of functionality available there, but allowing you to sort of standardize, if you will, kind of entry points and threat management in terms of the environment. Obviously, it's important when you're thinking about deploying the footprint to decide on what types of instances you want to use. We actually provided here. It's in the template. It's in the template. It's also in the the white paper are kind of the standard instance types or standard sizes that are requirements. So there's some minimum requirement values up top, and then obviously the next table down, it gives you the idea of the standard ones that we use for the CloudFormation template. And those are controllable. As you launch the template, you can choose instance types you want. But these are the ones that are in the template by default to give you additional capacity. Obviously, there's a whole bunch of information on Microsoft's site about how to size your environment. There's detailed guidance there in terms of users and workloads involved. So I definitely run through that process to size it appropriately and then pick the EC2 instance types that map to that particular need. There's also, we use Amazon Elastic Block Store for our core boot volumes. And so that's, those are actually, we use the GP2 or general purpose volumes that we recently launched. And these actually are SSD backed and provide a good, consistent performance. But obviously, you could swap those out for driving even higher performance for PI ops, but we haven't found it necessary in the initial architecture. There's one thing that's important when you look at how you deploy your topology. So as I mentioned, there's the traditional topology as well as the streamlined topology. If you were doing a traditional topology, you might say, I want a minimum of 2 SharePoint servers per AZ as a start point, right? It gives you a high availability. It gives you your minimum number of servers for deploying the actual infrastructure. And that would be something you can set in the template. When you launch it, you can set the number of SharePoint servers per AZ, and that will sort of drive you to these different core architectures. So a minimum number of 2 for high availability. You'll get actually 4 servers in that case. You'll get SP and SP1 and SP2 that will receive the HTTP request. That's the web tier. And then SP3 and SP4 will be the app server or batch processing functionality. So you actually have a 2-tier web tier, app tier, database tier model if you pick the 2. That's the default. With 3, you would get additional ones. You'd actually get obviously SP1 and SP2 for load balancing for web traffic. 3 and 4 would do app server batch processing functionality, and then 5 and 6 could be used as dedicated distributed cache or specialized workload servers. That's when you need to start. You're starting to move into the streamlined model, but not completely. You still have compressed, if you will, compressed footprint across the server footprint, but you do have an extra layer for maybe some isolation of particular workloads. And then when you get into a full streamlined model, you would choose 4 SharePoint servers per AZ. And there, you can actually have enough infrastructure for a larger farm. Now you have distribution between, the web tier as well as the distributed cache tier, and then there's a request management, batch processing, and specialized workload layers as well. So you really have much more detailed breakdown. So if you're thinking about how to pick the topology or pick the footprint you need, you would actually just choose the number of servers per AZ, and it kind of drives you into the traditional semi-streamlined, fully streamlined would be the way I might describe them, architectural models. So let's talk quickly about the steps, what we need to do. The steps are fairly straightforward. It's a 2-parter, or a 3-parter, I should say. The first is to launch the SQL Server Enterprise Edition backend. So you want to obviously have your database in place. That's the first thing you want, because obviously everything else will reach into it and needs to exist as part of the creating the environment. So this actually uses the Windows Server Failover Clustering, WSFC, as well as SQL Server Always On components. So you do actually have a highly available model of 2 servers and a mirror. And so that's part of as I mentioned before, the other webinars we have. One of them is all about the WSFC and SQL Server Always On. And so I definitely watch that. But there's a stack specifically dedicated to that, which spins up, remote desktop gateway and domain services and SQL Server Enterprise and spins up and configures the environment specifically for the SQL Server Always On. The next step is to prepare a media volume snapshot. So this is the install media for SharePoint. So what you have to do is then download and put it on a disk. We don't provide a snapshot of our own of it. You have to then download it and install it and copy it into a particular volume and then snapshot that, and then you can use that inside your environment. That's obviously to keep in line with Microsoft requirements around downloading and installing software. So you prepare a media volume snapshot as that next step, and you can see the dialog boxes here kind of highlight what's happening there, where you create an instance, you create a volume, you attach it, you then connect to that instance you attached it to. Is the next one. You can see where the elastic IP is there to show you how to connect to it using the remote desktop gateway. You then copy the content into the folder in that fourth dialog box, and then you can create a snapshot of that. And that snapshot is now your install media, your ISO, if you will, for the SharePoint stack, which then you can attach to all the other servers and install dynamically as they launch. And then the third step is to launch the SharePoint Server 2013 stack. And in that step, it goes through and actually spins up all the layers, the web tier, the app tier, depending on the servers per AZ, it spins up different numbers of servers, and then connects them to your existing SQL Server Enterprise data store. And then you can log in and go ahead and configure that. So the template itself that exists, and I'll look at it in just a second, takes about 3 hours to complete end to end. And based on the server footprint we pick by default, it costs approximately $9 an hour, which means it's about $25 for the whole thing. It's kind of a round number in terms of how much it costs to test this whole thing out. You have 30 different parameters to modify and set up the template as you want, and that's actually linked directly from the actual white paper itself. So let's take a look at the templates themselves. Let's start with so you can see the SQL Server Always On is the first one you'd run, and that actually creates the SQL Server infrastructure. I won't spend a lot of time here because it isn't the core of the environment, but you can see it allows you to choose your instance types. You can see here these are all parameters. So you can see node 1 instance type, node 2 instance type. These are all various parameters that are passed in. You can choose domain names and control those things, Active Directory information. And then once all those, you can create obviously your SQL Server service account, the default, account password. So all these things can be defined on the template as you launch that SQL Server infrastructure. And it will go through the process of creating and running the entire infrastructure. And you can see here that it actually will go ahead and create it'll actually call and invoke other stacks. So for example, here it'll create the AD stacks. Let's start up here. It'll actually create the Active Directory stack here. It actually calls another template, which you can see linked here. And that actually creates the Active Directory from the components. So you can see CloudFormation allows you to embed other templates inside of it. So obviously most of the focus in this template is about the SQL Server, but in order to have that, it needs Active Directory. So it spins those things up. And then the Active Directory would spin up the VPC pieces as well. So you can see it's more of a layered model in these templates. The next template is the SharePoint template. And you can see here, you have the information, for example, servers per AZ we talked about, a lot of values are 2, 3, and 4. So those are some of the components that are part of that template that allow you to drive kind of the architecture. As an example here's the SharePoint key. We actually include the trial key in there, but you could provide your own key if you want to use that for the installation as well. So it actually will embed the actual license key as well in the launch process. And then things like what size you want for web instances, what your DNS name should be. So for example, you might have a example.com might be your fully qualified root domain, but you might choose something different, contoso.com or whatever makes most sense. And then you can see you control a lot of the naming here. Most of these defaults work just fine, especially if you're spinning it up. So many of them you don't need to spend much time on. And then there you go. Let's see here. And then there's components in here like the include Office web apps, for example. Do you decide, do I want to include the Office web apps component? It'll add them or not. Things like that are then embedded here. Here's the ELB configuration. Do I want it to be internal or external? So these are parameters you can set on the template as you launch it, and it controls how it launches that. There's a whole mapping section, which takes care of mapping to AMI IDs. And then there's conditions. For example, if this equals 3, then that condition is true. If this equals 4, so it sort of helps to set some of the parameters passed in, set conditional parameters to be looked up later in the template in terms of launches. And obviously, here's where we get the resources, where we actually start spinning up the infrastructure. So SharePoint 1, and you can see that it does a whole bunch of work here. It does a set up, rename, join the domain, install the prereqs 1, install the prereqs part 2, install SharePoint 2013, and then finalize. So it actually, you can see here, setup does the CloudFormation CFN init, I should say, configuration to make sure that's set correctly on the instance. You then can see it'll install SP1 files, so it'll actually pull down some SharePoint installation PowerShell scripts that have been written that you can then look at, and then it will run those. That run this PowerShell script exactly, and then installing SP 2013 is another PowerShell template. So you can write these PowerShell scripts to do various components, and these are all publicly accessible, so you could go directly to these sources and find out, how those steps work. But you can see it creates, for example, it runs PowerShell and passes in parameters like the NetBIOS name, the farm account, the password, and the create farm, create key. All that kind of fun stuff is then passed into that batch process that's running. So there's a whole bunch of these that are passed in. You can see the commands occur, bringing the volume online, renaming the computer. So there's a whole bunch of PowerShell embedded in here. It's all fairly readable once you get used to the format. But that's how it's all pulled together. And so the full environment is fairly automated with some minor exceptions of obviously SharePoint configuration and setting up the media volume. So that's pretty much it. I don't think there's anything else. Post configuration steps, there's a few of those. So once you've set it up, you obviously need to configure your SharePoint farm. And so you can log into the SharePoint Central Administration. You can see SP:18473 is the default URL. Obviously, that port would have to be open. You'd have to be able to access it. You could do it. In many cases, it might make more sense to do that by using the remote desktop gateway server and jumping into the main node through that, and then doing it as a local request. So you're not necessarily trying to configure your administration server over the internet. And then of course you have to configure the Office web app servers. And then for HA and automatic failover, as part of the Microsoft SQL Server launch, which was that first step that spun up the SQL Server Enterprise, you do have to configure the always on availability groups and add the replicas to the second node. So those steps are covered as part of the WSFC and SQL Server always on availability groups webinar, as well as the white paper there. So if you think about this is really a sort of a layered multi-component architecture, and we've now got at this point published the complete set of quick starts and CloudFormation templates to deploy and automate the entire infrastructure.